Good day everyone. The aviation industry has set its sights on an awe-inspiring objective: to reach net zero carbon emissions by 2050. With the introduction of sustainable aviation fuel, SAF, and the advent of hybrid electric propulsion, the aerospace sector is already taking strides towards this goal. But what lies ahead on this journey towards a greener sky? In this video, we will embark on a journey of discovery as we delve into the CFM RISE Technology Demonstration Program. Get ready to take off on a thought-provoking and educational adventure, but let's first soar into the realm of sustainability in the world of aviation. Sustainable aviation fuel, SAF, is an alternative to traditional petroleum-based jet fuel that has the power to revolutionize the skies. By reducing CO2 emissions, SAF has the potential to reduce the environmental impact of aviation, which has long relied on kerosene and petrol. Imagine a greener future for flight, powered by a more sustainable fuel source. However, the future of flight is fueled by a rare commodity. Although supplies of sustainable aviation fuel, SAF, are expanding, they remain a scarce resource compared to the massive demand for jet fuel worldwide. At present, production of SAF accounts for less than a mere 1% of the total demand for jet fuel. However, as the demand for sustainable alternatives grows, so too will the supply of this game-changing fuel. Boeing and GE Aerospace have been blazing the trail in sustainable aviation for over a decade, conducting numerous thrilling flight demonstrations with sustainable aviation fuel, SAF. Their groundbreaking achievements include the industry's inaugural commercial biofuel flight in 2008, powered by GE's CF6 engines on a Virgin Atlantic Boeing 747, and the first-ever commercial flight powered entirely by SAF in both engines on a FedEx Express Boeing 777 in 2018. They continued to push boundaries with the first passenger flight powered by 100% SAF in one engine in 2021, using a United Airlines Boeing 737 MAX 8, and most recently made history with the first-ever Middle Eastern demonstration flight powered entirely by SAF in one engine in 2023 on an Emirates Boeing 777-300ER. These daring pioneers are shaping the future of flight. In addition to this, the partnership between Boeing and NASA has also been pushing boundaries. As part of Boeing's Eco-Demonstrator program, SAF combustion was put to the test with regards to particulate matter emissions. In 2021, an Alaska Airlines 737-9 equipped with CFM LEAP-1B engines served as the first aircraft to undergo this innovative testing. And in the fall of 2022, Boeing and NASA continued their groundbreaking work by conducting emissions tests on a GEnx-powered Boeing 787, running on a blend of 50% drop-in and 100% non-drop in SAF. These tests represent another step towards a greener future for flight. Let's talk about the CFM RISE Technology Demonstration Program. The RISE program has taken flight. Launched last year by GE Aviation and Safran through a 50-50 joint venture, this program represents a giant leap towards the aerospace industry's goal of net zero emissions and sustainable flight. Drawing upon 4 decades of investments aimed at making engines cleaner, quieter, and more efficient, the RISE program propels the development of new propulsion technologies, charting a course for the next generation of aircraft and paving the way for a greener sky. The next generation CFM engine is poised to soar into the skies by the mid-2030s. This revolutionary engine will deliver a reduction in fuel consumption and carbon emissions of over 20% compared to today's most efficient engines. And, with compatibility for alternative energy sources such as sustainable aviation fuels, SAF, and hydrogen, this next-generation engine is set to lead the charge in the pursuit of a more sustainable aviation industry. The RISE program is leading the charge towards a new era of propulsive efficiency. With the concept of an open-fan engine at its core, this program has been driven by the growing need for increased efficiency. Over the years, engine fan diameters have continued to grow, with the GE90 being the largest engine for wide bodies and the CFM LEAP series leading the pack for narrow bodies. However, there are limitations to how big and wide engine fans can be in terms of aerodynamics, stability, and sustainability. The RISE program is challenging these limitations and forging a new path towards more efficient, sustainable flight. The open fan design breaks the mold of traditional jet engine concepts, boasting a cutting-edge 14-foot fan at the forefront and a ring of adjustable, non-spinning stators in the back. This unorthodox approach aligns with the idea that maximum fuel efficiency is achieved by pushing massive amounts of air at the slowest possible exhaust speed. The revolutionary new open fan concept bears no resemblance to a turboprop engine. Upon maturity, this visionary design will soar at speeds rivaling those of current single-aisle aircraft, reaching speeds of Mach 0.8, all while emitting a tranquil hum that complies with anticipated future noise regulations. CFM has charted a comprehensive roadmap with over 300 unique components, modules, and full engine prototypes to refine and perfect the technology. Enter GKN Aerospace, a key player in the collaboration, which rose to prominence as one of the world's top multi-technology Tier 1 aerospace suppliers following its acquisition of Volvo Aero. With its expertise in developing, constructing, and delivering a wide array of cutting-edge aerospace components, systems, and technologies, GKN Aerospace brings a wealth of capability to the table. GKN Aerospace's Swedish branch, with a well-deserved reputation as a design authority in the aero engine space, particularly in the realm of cooled nozzle extensions and turbines, brings valuable expertise to the table. As a rich partnership in the demonstrator program, GKN Aerospace will infuse the latest in component design, technology, and hardware production, all with the goal of supporting the program's objectives and eventual validation plan.